Alright guys, welcome back. Appreciate you guys keeping up with the videos. We're going to be looking at chapter 6.6, Fundamental Theorem of Algebra. Alright, feel free to jot it down. Alright, it states the following: every polynomial function of degree n greater than or equal to 1 has at least one zero, where a zero may be a complex number. Alright, a corollary, right, which follows from this theorem. Okay. And it will clarify that every polynomial function of degree n, 1 or greater, has exactly n zeros, including multiplicities. Okay, and if you've looked at and followed that word there, multiplicity, it just means that it can have the same zero repeated twice, 3 times, etc. Right? Anyways, let's take a look at this example. Write the simplest polynomial function with the following zeros. Okay. Now, because they're guaranteed to be zeros, okay, we do know that, right, this is essentially what our function, our polynomial, will equal with these as factors. So we can simply come in here and insert them as such. Okay. So we can go ahead and maybe create the whole skeleton thing again here. Right. And this is a good tip because it'll avoid small mistakes that can have huge consequences. So I'm simply going to insert -2, which switches the sign, a 7, which retains the minus, and a -1/2, which changes the sign. Okay. Hopefully you caught on to that. And now, because we've been essentially given the factors, now we can compose this thing to what we call the original polynomial. Right? Essentially what I'm going to do is the opposite of before. Now I'm going to multiply these factors versus given factor, then dividing right into its factors. So here I have x times x, x squared. I will be ignoring this factor for a second. Okay? So this is good practice for some of you guys who missed this essential skill or kind of forgot it. Okay. Then I distribute him to him, -7x, him with him, plus 2x, him with him, -14. Alright. So we will speed it up in a bit, so make sure you understand where everything's coming from. Right. Now, this is this portion right here. So I can't forget to include this guy. Bring him along. Right. Here, from this step to this step, I've simply combined like terms. And now the only thing left to do is take this binomial and multiply it into this trinomial. So here we go. We get some room here. Alright, so very simply, this x will get distributed to these 3 terms. Then I'll move on to this half and distribute him that way. Okay. So we're left with x cubed minus 5x squared minus 14x, his turn. Okay. Half x squared minus 5x and minus, whoops, I was going to just put minus 14, but it's half of 14. So it's a -7. Alright. And the last step here, I'll be combining like terms. I'm looking for my highest exponent. There he is. He's got a square, so does he. So that becomes 4.5. He's got an x, so does he. So that'll become... Alright, this is a whole fraction exercise. I won't labor this video with that, but besides the calculator, you would need a like denominator. So here this is -28/2, which gives us -33/2x minus 7. Alright, let's see here. Alright guys, so now we're going to move on to a second example. okay, called the complex conjugate root theorem, or at least it involves this theorem. It states that if a plus bi is a root of the polynomial equation with real number coefficients, then a minus bi is also a root. So long story short, if this is a given root, then this is implied. It may not be given, but it's implied to be a root. Alright? Very powerful. So write the simplest polynomial function with the following zeros. Here you have 2 minus I. Right? So let's take a look at what was stated here. If a plus bi is a root, then a minus b. So in reverse order, if a minus bi is a root, then a plus bi is a root. Okay, so let's go and jot that down. So here we have 2 minus I is a root. So that theorem guarantees us that 2 plus I is a root. Alright, and given also is the square root of 5 as a real root. Now implied, and this goes back to our use of the quadratic formula, okay, the whole plus or minus. So if square root of 5 is stated as a root, then the negative square root of 5 would also be implied, and then we've got negative 2. So understand that this is coming from that theorem we just looked at. This one's coming from the irrational root theorem. Okay, if you want to write that down. But bottom line is this concept that if one's given, the other one's implied. Okay. Alright, with that said, let's go ahead and get started here. We do need the simplest polynomial function. So we can go back to what we just did on the previous problem, where our polynomial, we set it equal to 0. And specifically, we can do so because we know these are the given factors. So to avoid any mathematical errors on my part, I'm simply going to create the skeleton. I've got essentially 5 roots or zeros, so I'm going to create 5 of these. And now I'm going to insert here, right? Because we've got a lot to work with, I guess I can go with a different color. 2 minus I. This one is 2 plus I. Here we have square root of 5. Here we have plus square root of 5. Here we had a minus sign. Now this negative will turn it into a plus. Let's see here. Alright, now these two in particular and these two work out in a very unique way. So you do want to, although you could multiply them in any order, you want to take a look at those specifically. Right? So let's go now start off with the multiplication of these two. Here, and again, this is just an exercise in multiplication, okay? So don't overcomplicate things. So I'm going to have here x times x is x squared. X times that is minus 2 plus I x. Here I have a minus 2 minus I. And next up I have these two. So negative times the negative is going to be positive. Alright. I'm going to do the math in here. I'll do it in brackets. Notice that this itself is going to get foiled, this stuff in blue. Okay, so 2 times 2 is 4. 2 times I is plus 2I. Negative I times 2 is negative 2I. And negative I times positive I is a negative I squared. Okay, this should look familiar to you guys. And now you do want to observe that there's a lot of work happening just for these two. Okay, so keep in mind, we'll take inventory of them after we clean up some of this math here. So we're left with x squared Okay, if you distribute this, let's go ahead and kind of write these out. Negative 2x plus ix. Right. Let's just double check this term. Right, so this one came from this multiplication, this one comes from these two, so it looks like we need to include the x there. So let's continue. Where are we? This distributes negative 2x. This distributes, that should be a minus. Okay, a minus ix. And this portion here is a minus 2x. This is a plus ix. So far we've covered up to there. Plus, let's take care of the math in here. This stuff's going to cancel 2i minus 2i. And we're left with 4 minus I squared, if you guys remember, is equal to negative 1 from last semester. So let's continue cleaning up the math on this. So we got x squared minus 2x minus ix. As a matter of fact, let's go and combine like terms at this point. So he's been taken care of. He and he can be combined. Okay, he and him are opposites, so they're eliminated. And then lastly I have 4 plus 1, which is 5. Right. Okay, so everything's been addressed. Now let's go and carry on with the rest of these guys. Minus square root of 5 times x plus square root of 5 plus 2. Okay, so those additional zeros, I've brought them down. Okay, so now we can move forward confidently. He's been taken care of, so now we've got to go ahead and worry about these two for a little bit. Alright, we'll bring these down in a bit. So let's kind of hasten some of this FOIL process. This should be x squared. This is a plus square root of 5x. This is a minus square root of 5x. That'll cancel, and I'm left with minus 5. Okay, bring this guy down. And then bring this portion down as well. Alright, it's time to look a lot neater and cleaner. So now we must continue carrying out the multiplication. So let's go and distribute. We'll ignore this guy till the end. For now, I'm going to distribute this x squared to these three. So I've got x to the 4th minus 4x cubed plus 5x squared. Okay, now the negative 5 will get distributed. I got negative 5x squared plus 20x minus 25. Alright, so I don't forget, I'll bring this guy down, although he's kind of being ignored for a second. Let's go ahead and combine like terms. Here's my highest exponent. Here's a cube, no other cubes. Here's a square, there's a square, they're opposites, that's gone. Plus 20x minus 25. Here's a simplified version. Once again, look at the repetition. It is a lot of multiplication, but at the end of the day, it's just multiplication. Something that you need to work on anyway, so this is good practice. So here, last time I will distribute this x across the board. X to the 5th minus 4x to the 4th plus 20x squared minus 25x. And this 2 will get distributed, plus 20x to the 4th minus 8x cubed plus 40x and minus 50. Alright, let's do it one last time. Let's clean up this hot mess, get this over with. X to the 5th is my highest exponent. Next is all the x to the 4ths, which is this guy and this guy, giving us negative 2x to the 4th. Done and done. I now need my x cubes. He's the only one. Negative 8x cubed. Done. He's got a square. He's the only one. So plus 20x squared. He's got an x, he's got an x, so that comes to 15x. Done and done, and minus 50. Guys, it was a longer than usual video. Hopefully all these steps help. Thanks for your time. I'll see you tomorrow.